Hello world! So today's video we're going to be talking about digital manufacturing, which will be critical for colonizing Mars because we'll have to make most of our stuff there. So let's talk about CNC Basics. CNC stands for Computer Numeric Control. It's basically the marriage of software and hardware to produce products. Starts off with a design, whether that's a 3D design or a 2D design. And then from the design, we go and we do a toolpath synthesis. This is the actual toolpath that the machine head will follow as it's cutting or engraving or printing. From the synthesis, we get out what's called G-code, which is a plain text file that tells the machine when and how to move and all the details of the build. The motion controller is the first step into the real world. It has a firmware that interprets the G-code and sends out the proper signals for the various parts of the machine to complete the part. So the motion controller sends out what's called PWM waves to the actuators. We'll get to the details of PWM waves in a minute. The actuators are what make the machine actually go movie and follow the toolpath. Now, the machine also has inputs, which are a variety of sensors. These sensors can be anything from switches to temperature sensors to optical sensors to emergency stop sensors. They're how the machine knows what's going on in the real world. And finally, we have the tool head of the machine. This could be a laser, it could be a 3D printer extruder, it could be a milling head. There's a large variety of different tool heads and different CNC machines. Alright, let's talk about the CNC software. So the first step is the design software. And design can be split into 2D vector, 2D raster, or 3D CAD. I try to use all open source software. So for 2D vector I use Inkscape, for 2D raster I use either GIMP or Paint.net, and for 3D CAD I use Blender and OpenSCAD. The commercial proprietary closed source equivalents for 2D vector would be Adobe Illustrator, for 2D raster would be Photoshop, and for 3D CAD would be Autodesk or Rhinoceros 3D, or there's any number of commercial 3D modeling programs. So now let's talk about synthesizers. These are what generates the toolpaths for the different designs and tells the machine where it needs to go to render the design into the real world. For 2D vector, I use DXF to G-code, which is a simple open source vector G-code creator. For 2D raster, I'm setting up LaserWeb, which can also be used for 2D vector. For 3D CAD, I use SchemeForge for 3D printing. I have also used Slicer for 3D printing. And I've been experimenting with PyCan. Of course, there's a lot of other synthesizers out there, both commercial and proprietary, but these are the ones that I've been focusing on. Alright, so let's continue on to the CNC hardware. For all of my CNC machines, I'm actuating with stepper motors. These motors take in what's called pulse width modulated waves, or PWM waves. So how a PWM wave works is firmware changes the widths of the pulses, and based on the widths of those pulses, the stepper motor moves forward a step or backwards a step. So then for sensors, in my systems I have two main types of sensors. I have limit and home switches. For my 3D printers I have temperature. And now for the actual physical hardware. The CNC systems I use are all gantry based. So what that means is you have a arch over your build platform. There's three axes of freedom. There's the x-axis, which moves the tool head back and forth. There's the y-axis, which moves the entire gantry forward and backwards. And there's the z-axis, which moves the tool head up and down. In my follow-up videos, I'll be going more in depth on how these frames are put together for each of my different machines. So as always, if you want to follow along, please subscribe, and thanks for tuning in today.